All right, let's take a look at this electric force in a line problem with multiple charges, okay? So what we're gonna do here is we're given a situation and the question will ask you what charge to focus on. Every time you go into this problem, you are getting a new situation. So really try to do your best not to, you know, like really try on it. Otherwise, you're going to have to start all over again. Now, theoretically, you set the work up properly. You just have to change the values. Okay, so a couple things to note. First of all, we're in nanocoulombs, so we need to make sure we're changing those to regular coulombs, which is 10 to the negative 9. All right, and second thing is we're in millimeters, so our distances need to be in meters and millimeters. We got to convert those with 10 to the negative 3. All right, so one of the questions that it is asking you is to draw a force diagram on this. All right, and so that you can do by hand and insert a picture, or you can insert arrows into your document, however you want to do that. All right, but once again, just like in our notes, we have to look only at the force that is in question. So let me clear this here. So in this case, I am being asked for Q1 right here. Okay, so if I were to draw a force diagram of this, and I'm going to do it just right above here. So here's Q1. Okay, I'm going to look at Q2. Q2 is blue, therefore I am, and it says negative, so I know it's going to attract it. So it's going to be going in this direction. That's the force of 2 on 1. All right, and then I look at Q3 is red and it is positive, so I know it's going to repel it. Not only is it a smaller charge, but it's further away, so I know my force on that is going to be quite a bit smaller. I am not drawing this to scale. I know a lot of you in statics are getting used to drawing things to scale. If you want to, that works too. It's better to, but as long as I can see that they're in relative in size, what they look like. Okay, and your situation might be different. If you can't tell whether they're different, then you can draw them the same length or relatively. But remember, it's a direct relationship to the charge and inversely squared to the distance. So the distance is going to have more impact than the charge. All right. So already I could answer my last question of the direction. Okay. So I know that Q2 is applying a bigger force. Therefore, it is going to go to the right. So I would leave that as the right. I would not change that to the left. Okay. So now when I go to do this work here, okay, I know I'm going to have, you know, my charge of F of 2 on 1. So I'm going to do my F of 2 on 1, K, Q1, Q2 over R squared. And then I'm also going to have my smaller force of 3 on 1. And so I'm going to calculate those two, Q1, Q3. Over R squared. And then in order to get my net force, I know I'm going to subtract those. So it's going to be F2 minus F3. Okay. Now, here's the tricky part. This program is actually quite particular, so do not just estimate these distances. Okay. Also, remember that it is not just the position. Right here, if I called that 26, that's the position. But we're looking at the distance here, right? So if that's at 26, and sometimes it helps if you zoom in and be really specific. So my red Q1 is at 7. That's a terrible color, sorry. Is at 7. Okay, and Q3 is at 26. All right, so then I can determine the difference between those two in order to get my R for that value. And then same thing when I'm looking at F2. Okay, if I zoom in, I'm at 15, 16, 17, 18. Okay, that's at 18 millimeters. But again, my Q1 is at 7. So I'm going to look at that distance between those two. And then my distance between those two in order to determine my R values. Okay, and again, before I do that, I need to remember those are in millimeters. So when I put my R value in, which is squared, I need to make sure that number is in millimeters. All right, and then my Q's are obviously in nanocoulombs, not regular coulombs. So then when you enter your force and click check, it will be in there. Okay, it'll tell you whether you're right or wrong. It'll tell you what it got for the distances, what it got for the forces. That is the actual, and your values entered was the predicted. Okay, just note that it has a variance of, I think it's like 3 to 5% that it accepts. Try not to round. It actually is better if you keep a little bit more significant figures, which is against what I say, but the program is the program. It's not a thing thinking. So it just looks how close it is to what the calculation actually is. All right, and if you check that rubric out, remember on the rubric, it does have variations of if you were really close. Okay, if you can make a determination whether you want to redo the whole thing or submit what you got. If it's green, it's great. If it's red, please take a look because it'll be red even if you got this right, but this was wrong, it'll still be red. So really actually look at the feedback that it gives you on what it wants. And if you're way off, you can hopefully figure out what you did wrong. Maybe you forgot to convert, maybe you use the position instead of the distance between the two. So use that to help you out. Okay? All right.